Hi guys, welcome to Learning Electronics Repair. So in this video we're going to investigate whether AI, or as they call it here in Spain, IA, can help us to identify electronic components, particularly SMD ones with these funny little SMD codes on. This video is actually recorded over several days at different times. I've done a little bit of work on this and come back again, so I may change my clothes and it may seem a little bit disjointed at times. But anyway, this is what happened when I tried to use AI to help me to find data sheets, or at least part numbers, for little SMD devices that I cannot easily identify. Let's see what happens. Out of interest, by the way, I can't find any datasheet for this chip, but we can have a quick look. In fact, we can ask AI, see what it says. So I'll ask for a 20-pin DIL dual line IC marked 6600. Okay. In fact, let's go to ChatGPT and ask that, seeing as it didn't bring AI up anyway. So ChatGPT, okay, let's have a look. Okay, it says it's challenging since that mark to learn is ambiguous. And it gives me a few things. So it's saying low noise differential amplifier. It ain't that. It ain't an ADC. It's none of these things. Okay, why is it tricky? ICs often use internal shortcodes. Okay. What to do next? Examine the circuit around the chip. And it gives us a few ideas here. Okay. So we do know a bit more about this chip. Identify 20-pin DIL IC marked 6600, likely a combined PFC and resonant controller. That's because I know from where this is in the circuit, basically what it is most likely to be. Okay. You're on the right track, given the context. Couldn't find it. However, there are some closely related devices, so it gives me some suggestions now. Well, that says it's a SOIC, so it's a wrong package. That one is not a PFC combo. Actually, I don't know that it is a PFC combo. It doesn't matter the 20-pin. Okay, and that's also not 20-pin. Okay, so let's remove PFC, because I'm not sure if it is a combined controller. Admittedly, if it isn't, and I don't know where the PFC controller is, in RATXPSU, likely a resonant controller. Let's go with that. Now it gives me FAN6600. Okay. Designed for controlling resonant converters, typically used in the PFC and LLC stage. This sounds very likely. That one. It does suggest the PFC controller would be a different chip. Okay. And mentions could be just 6600. So actually, this is really quite useful, don't you think? I know the model of the power supply, so let's put that in. How about that? Okay. Mark 6600 in an EVGA 1000 GQ ATX. And it brings us to the same thing. Okay, let's look at the datasheet for this. Well, apart from the fact I still can't find a data sheet, at least the AI helped me so far. Maybe ChatGPT knows where that is. Okay. Well, it tells me it couldn't find it, not publicly available, but it does mention other similar ones. These are flyback. No, this is 8-pin, so no. So basically it says not available, and there are related devices, but those are 8-pin devices, so that's not going to help me in this case. At least that one is 8-pin. Let's look at this one. Well, no, this is for flyback converters, so it's for the wrong type of power supply, so that isn't going to help us either. And completely different device. Okay, so we can use AI to help us find components, datasheets and such like. And I think it probably has identified what that chip is, but I can't find a datasheet for it. Now then, the question is whether AI is more intelligent than humans. Okay, so you guys out there, can you beat ChatGPT? Is it still not ready to take over the world? Hi guys, welcome to Learn Electronics Repair. So today we're going to find out whether AI can help us identify particularly SMD components, but basically any components that we can see that we basically can't find a data sheet for. Yeah, well, we don't know what they are. So I'm going to use ChatGPT version 5, the recent one, the latest one. Obviously there are other options. I have a bit of a variety of boards here, quite an old laptop, power supply out of a TV, some sort of switching board or something with lots of relays, so a mixture. This is out of an old Apple power supply, okay, from some sort of all-in-one computer. So that's what we have. Let's have a nosy around, look for some components, and then see if we can identify them. Okay, so this is a partly dismantled switch mode power supply. I think you would probably all be able to identify this now as a switch mode power supply. If not, ask in the comments how I would know that. We can talk about it. But we can see components on here. This one, LT7B48, and then SHJC. It has a line down there, so it's polarized. Looks like a diode or a polarized capacitor, probably a diode, and we can actually check that, so why not? Let's see. Looks like a diode, probably a fast rectifier of some sort, but we'll keep that to ourselves for the moment. Let's see what ChatGPT thinks. So normally I would actually put this into Google and look for a data sheet. It's found something but LTV847, not the same number, just a bit of a mix up on that sort of. LT48, it's got a 7B in it. This appears to be the right thing, but if I click on it, it's just a list of parts basically. Certainly not data sheets. And I don't find anything else. So let's try AI. Or as they call it here, by the way, IA in Spain. Inteligencia Artificial. Yeah. IA. So I've just typed into ChatGPT, and I'm using the free version, by the way. I say free version. I'm not logged in. I'm not on ChatGPT 5, which is the latest version of this. It's whatever version it's giving me. And I've just typed, I'm trying to identify SMD components in the code. I haven't told you anything else. Let's see what it says. No exact match, okay. LT codes are present but non-continuous that. L7 codes include something similar, low voltage dropout regulator. The segment 7B also documented the database but not the full match, okay. So it says the exact code isn't listed, a few possibilities. It's a combination of two distinct codes. Could be LT or 7B48, okay, or misreading part of the code. It's then recommending examine under a microscope, yeah, see if it's smudge scratch. What device or board is it off? Okay, location or function, are there any clues? Is it a diode, regulator, transistor? Okay, so we can tell it some things. It is a diode. And because it's at 0.4 something, fast switching diode, okay. The PCB is from an Apple all-in-one computer, but I don't know the model. How about that, yeah? There are some markings on here, Delta Electronics model, but it's all in Chinese. Oh no, we have a model number there. Okay, so let's see what it tells us now, and then I will give it that information as well. Okay. Again, it couldn't find the exact, okay. And it's given me kind of device context, fast switching diode, Apple all-in-one motherboard. Okay, I'm going to tell it's the power supply out of the Apple all-in-one, not the motherboard. Okay. Now it's asking me what package it is. Now I don't know, but I could measure it. Okay. So, the diode is not on the motherboard. It is on the switch mode power supply. The PSU, I've mixed terms here, why not? PSU. I'm talking to almost a person, you could say. Delta Electronics, and then ADP 185. Looks like B 185, and then I can't read the rest. Okay, let's tell it that 185, and then something unreadable could be letter B. Okay, tell it that. It still isn't finding it. Okay, still isn't finding it. Well, there's another number on the chip. So it's also marked S8JC. And it's also said it can do a visual capture, take a well-lit magnified photo of the diode from above, showing the marking, okay. Note this package type. It's asking where it is in the circuit. It's giving me some substitutes, possibly. Just replace it with a Schottky diode, the highest rating in the same package. Okay. The diode has another marking. And it's approximately 7 millimeters. Let's say 6.5 millimeters by 5.5 millimeters. Okay. S8JC, and is approximately 6.5 millimeters times 5.5 millimeters. Let's see what it says now. Oh, I've messed out the thing there. So let's come back. Sorry, the other marking is SHJC. Stay logged out. Now it's sending me a picture of an SHJC diode. It's giving me the package type. Closely matches the size you provided. 6 by 5 millimeter. This visual aids. Okay, so now it says it basically knows what it is, and we have some information. And then it's giving me some information on how to choose an equivalent. Okay, so it's a general rectification diode. Let's ask it for some equivalents or commonly available. Yeah, please recommend a commonly, I spelled it wrong, let's spell it wrong, commonly available substitute. Yeah, or shall we say equivalent? Let's say equivalent. Okay. How about that, guys? How about that, yeah? Yeah, it's saying that one's a through hole, but if you can fit it. This one. Okay. Best drop in there. And it's telling you where to get it from. How about that, guys? Yeah? That worked. I think you'll have to agree with me. Pretty impressive, in fact. Okay, guys, a couple of days later, had stuff to do. I'm back with this one and back with ChatGPT. So, this device, CYT. I've asked ChatGPT just basic question. Can you identify an SMD device marked CYT? So, we got it a slightly different way. It's saying TVS diode, transient voltage suppressor diode. But that is in a completely different package. That's a diode type package as we would recognize it. CY could be a small Zener diode, but CY or CY1, but not CYT. Okay. I'm going to tell it now a little bit more information. So I'm going to say it is 3-pin device like SOT23, but a bit smaller, possibly SOT323, which is that one. We can measure them, okay, but I'm pretty sure it is that one. I'll tell it possibly SOT323. So it's given me the sizes, which we could measure with calipers. Back to the component. Yeah, it agrees with what I said. It's the other one was the wrong package. Either a different device or the marking is worn. Measure the components, where it sits on the board. Examine the circuitry around it. Use a multimeter or component tester to understand if it's a switching transistor diode, etc. Okay, let's see if we can do that. Okay, so I've connected the ground of the curve tracer to ground. Does that connect to the emitter on our device? Let's have a quick look. So this is the device. This would be the emitter or source. So no, it doesn't connect to there. Okay. No point actually connects to ground. Let's apply the 5-volt pulse from here to what would be the base or gate. What's it do? Well, it appears to switch, but in a rather strange way. Let's go with the pulse on the other pin. What's this do? Oh, look at that. So this acts in a really strange way. It's not a transistor, I would say. Look at that. Yeah. Interesting. Let's see what AI thinks. The device reacts to a signal on what one would consider the gate or base. I use the curve tracer to measure on presumed collector emitter pins and put a 5-volt pulse on the presumed base. It reacts to the pulse, but nothing like I would expect a transistor to do. Okay. Okay, but not in the way that. How about that? Not in the way that I would expect a transistor to do. Oh, great diagnostics. You've done some solid detective work. Let's piece together what you've observed. 3-pin SOT323, similar. Mark CYT, device responds to 5-volt pulse on one pin, which I believe to be the base gate. Use the curve tracer and observed unusual behaviour, not matching the standard NPNP or MOSFET, collector emitter or drain source pair. Show unexpected characteristics. What could it be? Unlikely transistor or MOSFET. Responds to an input signal but does not behave like a typical switch or amplifier. Agreed. There's a class of 3-pin devices often mistaken for discrete transistors or FETs. Okay. Digital transistor. Looks like a BJT. This has internal base resistance. I know about this one. I don't think it's that one. Okay, weak conduction until the base current exceeds the internal resistance threshold. Oh, it could be that one. Gives me some suggestions. Or a protectional clamp device. Okay, that's what it's saying. Behaviour, no conduction until exceeding the breakdown. I would have thought it'd be higher than 5 volts. Not typical to respond to 5 volts. Okay. It says the normal use for dual diodes or matched transistor pairs. Oh, maybe something like a Schottky, but that's not a matched transistor pair. 3rd pin maybe common anode or cathode. Okay. It's suggesting gate-like input doesn't behave like a clean transistor switch. Curve tracer shows some reaction, but not transistor-like curves. Most probable ID digital transistor. Okay. And send me a photo of the package. Okay, let's do this. Okay, so I've uploaded the photo. I'll show you. Here's the photo. It thanks me for sharing the photo. Thinks it is probably SOT323. Huh? Not the larger SOT23. I think it knows that from the dimensions, or rather the ratio between the dimensions. It doesn't actually know the dimension, but an SOT23 is kind of like narrower. Yeah, like so, and wider, the aspect ratio. Yeah, it's saying that it clearly is box CYT. This is deliberate. It still doesn't know what it is, and it's asked me to try various tests. But what I've said to ChatGPT is I'll try unsoldering it and use my component analyzer, and it says that's a smart move, so do that. So I'm going to do that. It actually then goes on, by the way, to tell me how to use the component analyzer or send a photo of the results. Okay, let's unsolder it and see what we can find out. So I've added a bit of leaded solder to it. We'll use the soldering tweezers, desoldering tweezers. Yeah, that came off nice and easily. Okay, what I've done is I've actually soldered 3 wires onto it. I do have a analyzer that I can actually stick SMD devices and hold them against it, but probably just to make sure we have a good connection, and for the purpose of this video, let's do it this way. So I've connected the wires. The orange wire is going to what I would assume is the base or gate. Let's have a look. So analyzing. It's a PNP Darlington transistor. Okay. That would explain to some extent why the ChatGPT thought it was a digital transistor, okay? Let's tell it what we found out. And we have a pinout as well. But I would imagine this is the regular pinout. So blue goes to the orange, which would be the base. Okay, pin 2, which would be the collector, is the green wire, and then the red wire, which is the violet, is the emitter. Okay, so standard pin out. Let's tell ChatGPT. So I'm telling it which analyzer I have used. It says PNP Darlington transistor, pin 1 base, pin 2 collector. I think this is the way they go. Pin 3 emitter. I better just check this. Okay, so it's the other way around actually. These are 1, 2 and 3. Okay, I had that wrong. Better correct that. Pin 2 emitter, and I'm going to say this is probably why you thought it was a digital transistor. Well, this somewhat agrees with your digital transistor theory. Okay, let's see what it says. Especially PNP Darlington with built-in resistors. Okay, so it's now telling me what it thinks. Okay. Yes, that was a typo. Okay, so I just corrected the typo. Yeah. Likely equivalent DTA 114 series. So now it's actually found me a likely replacement for this device. Okay, mystery is solved. CYT PNP digital transistor, it says, or I've told it's Darlington. Oh no, it's going on to about digital transistors often look like Darlington pairs to testers. Oh, okay, so it actually thinks that it's not a Darlington pair, it is a digital transistor, that analyzers often mistake that. Let's see what the gain is of this thing. If it will even give me a gain. I think it may not give me a gain. And now it thinks it's a PNP silicon transistor. It's changed its mind. It says the gain is 195, so even the peak analyzer is a little bit uncertain what to call this thing. Yeah, now it's a PNP silicon transistor. So I'm going to actually tell ChatGPT that now, for whatever reason, the peak has given me a different answer. Interestingly, I tried again, and now the DCA55 thinks is a PNP silicon transistor. The gain is 185. Okay. Okay, so I have seen that happen before, by the way. So it goes on about the DCA55 can misidentify digital transistors, especially those with internal resistors, because reasons. Okay, and test method variability runs automatic test, applies small signals. Small differences can in the contact resistance, temperature, or how it biases. Okay, HFE 185, that's still suspiciously high. Not quite high enough to be a real Darlington. Okay, go on with that. But it still matches exactly what happens when the tester sees through the base resistor. So, yeah, it's pretty sure. It does actually say we can measure the resistance between the base and the emitter with a multimeter. If we see around 10k, that is a base resistor. Okay, and between base collector we may see another resistor. Let's try it. And I don't see any resistance there. Just check, of course, that the thing is connecting, the meter is working. Yes, it is. Okay, so base emitter, I don't appear to see any resistor. Just go again. Now the resistor should be a resistor, so it should be the same in both polarities. Okay, but we can swap. Mega ohms. Okay, I wouldn't call that a resistor particularly. Let's go to the collector. Okay. Again, mega ohms. So I'm going to have to go back to ChatGPT and tell it I've tried this and I don't read any resistance base emitter base collector. Okay. Right. In ohms range. And I do not see a base emitter or B-C, even better, resistor. Okay, what we do see, package, yes. Marking, yes. Behavior, sometimes PNP dominant, sometimes PNP transistor, yeah? With gain 185. Manual resistor, no. Pin out, what could it be if not a digital transistor? Few high probability options. Standard high gain PNP transistor. Okay. And it's given me some suggestions. Okay. No resistor B, yep. Not digital. The high gain makes it look like a Darlington. Oh, it's a matched pair transistor device, it says. But you normally expect a complex pin mapping on number 2. 3, special PNP transistor with unusual gain profile. Optimized for fast switching. Yeah, inconsistent behavior come from how those devices turn on or off. What you could try next. Test diode drop manually. Oh, yeah, okay. It's saying use, yeah, it's telling me now to use the multimeter in diode mode. Okay, or put it into a simple PNP test switch circuit. Summary. Most likely high gain PNP transistor, okay, with a manufacturer specific marking. If you're looking to replace it, something like this one. Okay, let's just try the diode mode test. Okay, so base emitter 0.662. Collector 0.657 with the black on the base. Okay. In diode mode, black lead to base, BC 0.656, B E 0.662. Yep, definitely confirmed it. Standard PNP junction transistor, yeah, no internal resistors, forward voltage closely matched, high quality junctions, possibly matched pair design, and it comes up with gain of 185, no internal resistors, SO23, final identification. And I broke it. I actually, would you believe it or not, guys, I actually caught the side button on my mouse at that point, and because I wasn't logged in, we don't know. This happens when you're making videos, guys, and unfortunately, from now, I can't get back into that tab. Okay, I can't actually get back into the tab. Can't get back to the chat. So, 2 lessons to learn from this. First of all, it almost told us what it was and then I screwed it up. Okay, this happens because I wasn't logged in. Okay, if I was logged in, it wouldn't have been a problem. So remember that, guys. Secondly, that yes, you can use ChatGPT to identify or help you identify strange SMD components, especially ones where you can't just go into Google and put SMD device and the code it tells you. So you can see that ChatGPT there was analyzing the thing, but it wasn't only ChatGPT doing that, it was me as well. So what was happening there as ChatGPT and myself were bouncing stuff backwards and forwards, different methods of proof, and it came up and told me what the damn thing was just before I hit the wrong button. ChatGPT is not like an online guru. It's more like an online partner, okay, to guide you, but you have to put some effort in of your own. Am I going to record this whole video again? No, because I want you to learn 2 lessons here. One, you can use ChatGPT to do this, but you have to put some effort in if you expect to get the best results. And 2, make sure you're logged in before you try something like that. Okay, down there, chat about it. I look forward to seeing you all soon on Learn Electronics Repair, and you'll probably have a good laugh now. Ciao.